Hi everyone, good morning or good evening, wherever you are. I'm Sagar. I lead the quality engineering practice at Innominds. Just to give you a brief introduction, Innominds is into product engineering services, primarily focusing on building the solutions, diverse technologies starting from device to cloud. So we do develop products on the embedded software, connected devices, digital apps, data, analytic solutions, and then cloud security, with more focus on AI adoption in software development lifecycle. And out of which quality engineering is one of the largest horizontal practice where we do end-to-end testing for any of these solutions using more focus on automation with using variety of tools and frameworks that includes commercial tools like Tricentis and open source technologies, and also AI adoption. So in this particular probably the session, so we will probably cover more on the how we transform quality engineering in software test lifecycle. And Sreeram is our senior architect who has 2 decades of experience in uh, exploring many of the automation tools, building the accelerators, and then building the reusable components on the platforms like Tricentis. So you will cover the rest of the session today.
Yeah.
Sriram, you want to take over from here?
Thank you so much, Sagar. Good morning, good evening, guys. Uh, that was a nice introduction. So today's topic is about how do we kind of transform the existing QE and SDLC software test lifecycle with AI adoption. To be more specific, so let's start. I hope you can see my screen, right? The PPT slides.
Yes, Sreeram, we are able to see.
Yeah. Okay. So let's start with uh, the typical challenges that we face in uh, quality engineering or maybe scaling up the existing quality processes. You know, if we follow a traditional waterfall model or the latest agile processes, the challenges are pretty much same. Uh, like as you see, uh, you know, the common problems, uh, would be categorized into, frequent builds or, parallel builds where developers would frequently throw at the QA teams for testing. Then the second problem would stem from your manual test case design and then updating them because of the frequent and parallel releases that happens frequently. And then with the increasing technology mix, with uh, complex UI and backend frameworks, complex application landscapes which span across enterprise applications all the way from progressive web apps and so on and so forth. And last but not least, how do we do the traceability in this shrinked QE test life cycles? And on top of that, we have this wide varieties of frameworks uh, for doing your UI automation, API. I mean, for doing end-to-end automation without unified visibility. So these are the typical problems that we face, that industry typically faces, and how do we actually kind of address them, and why the traditional testing can't keep up or scale up to the demands that are posed by the challenges that we discussed just now. So what are so as I said, so the challenges span across multiple phases. As I said, it spans across legacy systems, testing your complex landscapes, so on and so forth. So what are the things that we are doing wrong in the traditional testing life cycle, uh, be it in the manual testing processes or maybe doing automation. So traditional testing, like if you talk about uh, open source libraries like Selenium with Java combinations, or Selenium with Python, or even the recent JavaScript frameworks like Playwright and all, they are mostly script based automation tools. Now, when you rely on the script based automation, the biggest problem that we face is the maintenance of the scripts, and you are heavily dependent on the resources, the skills and expertise of the resources, wherein wherein when we kind of introduce the problem that I discussed just now, so that would complicate the problems further, wherein each release, like for example, the shrink releases, if there is a change in UI, like if we take the case of ERP systems like SAP or Salesforce, you would have, in an year, you would have probably 2 to 3 releases wherein they would completely change their UI, and your test case would break either because of your APIs that are changed or because of UI that gets changed. So when you follow this traditional script based automation, there is highly likely that your scripts might break, and we land into this vicious circle of maintaining your automation scripts, wherein you would slowly but steadily deviating from the business value. The original intention to develop your automation scripts in the traditional world is to enhance or improve the productivity or enhance the ROI to the customers. But because of this complexities that we are introducing, we'll end up into this maintenance problem, which is not significantly generating any return on investment. So that's where commercial tools like Tosca, Tricentis, Tosca, wherein low code, no code tools, which significantly abstract out all the unnecessary details of maintaining scripts, wherein Tosca, the model based testing, and uh, seamless identification of locators. So that's where most of the complexities that we talked about previously are kind of abstracted from a non-technical engineer, and even a non-technical engineer, if using these tools, can participate in this automation, wherein uh, the problems can be significantly reduced. So that is how we are kind of following them. But again, with the recent introductions of generative AI and AI, obviously we have to scale up from traditional script-based automations as well. Now, using your generative AI is no more an option, but we have to really ingrain into the existing SDLC processes, wherein we can significantly bring in more value add on the problem that we have discussed so far. So what is the message? The message is we have to have AI driven quality engineering. It is not a business enabler anymore. You have to, by default, like the way we have introduced Selenium or non or low code no code tools, AI is no more an optional anymore, and we have to introduce AI into your complete SDLC lifecycle. So that way, uh, once you introduce this AI-led QE, it would actually help in self-generation, then self-optimization, and self-healing. So that's where the AI would significantly bring in value add on the existing script-based processes. So I'll come to this slide. So what exactly we mean by saying self-generation, self-optimization, and self-healing? So self-generation, so when I say self, so basically your automation script should have some intelligent mechanism right from your test design, execution, and optimization phase, wherein right from requirements gathering phase, in the generation of test cases, rather than a QE, a manual tester spending a lot of time using the features that are provided by Tosca. You just use Tosca Copilot or maybe agentic AI. Just by simply providing your NLP kind of statements, it would It would generate the manual test case processes wherein you can talk to your Q test and you can upload your tests, wherein you can significantly save time in the test generation processes. That's where that's where we say self-generation. So rather than understanding the requirements manually, writing your test cases manually, and then doing the traceability stuff, if you introduce AI at every phase, when I say at every phase, right from test generation, test design, optimization, execution, we could significantly add value piece by piece, and then eventually you would have introduced AI into your existing SDLC processes. That's where you would save significant time. So we would see in the coming slides how actually we could do it with existing Tosca features, and how Innominds as a company is complementing the existing Tosca features to add a more value add. We'll discuss in the coming slides. Yeah, so how this generative AI, a part of AI, is actually transforming or reshaping the quality engineering. So we could pretty much use AI almost at every phase, right from requirement analysis, uh, from test generation. You can even use AI in defect pattern detection, regression optimization, and code summarization. When I say code summarization, automation code summarization. So how do I use AI in requirement analysis? Yes, if you have a well-written requirements or sometimes ambiguous requirements, you take those requirements and you take user stories or acceptance criteria from Jira, and then using uh, agentic AI feature or the features that are provided by Tosca, you can create a nice prompt and then ask the system to generate the test cases. That's where your AI would be helpful in requirement analysis phase. When in coming to your generation phase, I mean, requirement generation and analysis, pretty much the same. Where essentially, it's a test design. You can leverage your NLP statement for automated script generation. Then, while coming to your defect patterns, like we can write a connector, talk to your, Q test repository and Jira, understand the historical defects, historical failures, and then identify the patterns. And then using your intelligent prompting, you can ask what are the high risk areas that needs to be focused upon. Thereby, you can significantly reduce your regression cycles. Similarly, in code summarization, suppose if you have written a complex framework using model-based architecture, using layered architecture in Tosca, if a new engineer joins the system, it will be really difficult for a person to understand what are all the modules that are written, what are the action libraries, how the parameters are passed, so on and so forth. So you can just, because Tosca, using your Tosca Copilot, it would intelligently understand your existing repository of that automation framework that you have written, and by writing simple English like statements, that initial learning curve for a new journey would become significantly faster rather than spending a couple of weeks time to bring in the new user to up to speed. We can use this code summarization feature that is provided by Tosca using Copilot to bring them up to the speed, again by significantly reducing the time that the guy spends. So that's where, once you introduce your generative AI across your SDLC, and we can significantly reap in the benefits. Uh, I'll I'll pause and I'll give it the control to Bill to speak more about the slides.
Thank you so much, and thank you for that great introduction, because what I think we're talking about here is how our industry has to change and adapt because of what AI has brought, particularly to the development side of the house. And as quality engineers, how do we keep up? Now, I do want to hit on some of the points you've already made. First, introduce myself. My name is Bill Hayden. I'm an Enterprise Alliance Architect here at Tricentis. And it's my job to work with Innominds and other partners about not only where our technology is headed as a company, but how it's going to impact the industry as a whole. Tricentis has a really interesting background because it was founded by our Wolfgang Plotz in around 2007 on 3 core principles. 2007, Wolfgang looked around and realized test automation simply wasn't living up to its promise. Why? Because we were spending more time fixing our automation than running it, something you've already alluded to. So he developed, which he wrote about in his book, Enterprise Continuous Testing, these 3 core principles, at least 2 of which I'll hit on today. 1, what if we could actually do less testing, but more intelligently? And when we talk about sea lights, I'm going to touch on how that works. 2, which I think is really going to be a focus today, is around automation. The problem with automation was the maintenance trap. As you said, code-based solutions often required us to spend way more time in maintenance mode than execution mode. So what Wolfgang came up with was the idea to take code completely out of the equation, to create a visual model-based approach to doing test automation that we could even involve the business in, because they could understand what our tests were doing. And in that way, we really reduced that maintenance burden. Over the last 6-7 years, we further reduced that with some of the innovations you've already alluded to, such as self-healing, such as Vision AI. And now I'm proud to say that with our agentic test automation capabilities, which I'll touch on here in a moment, we're tackling the test creation process as well. So all this has really helped Tricentis explode over the last several years. I've been here 5 of those years, and I think I have watched the most meteoric growth in the history of the company. I have the privilege to talk about these ideas, where we're going and how it's going to impact the industry. In the last 2 or 3 years, as you can imagine, a lot of these have hit heavily on the realm of machine learning, targeted machine learning, generative AI, and agentic AI. So let's dive into that a little more thoroughly. I'm going to start by showing you our latest innovation, and then show you one of our first innovations that actually helps power that, which is Vision AI. Agentic test automation. What does that mean? That was introduced earlier this year in our product suite. Agentic simply means a generative AI that can take action on your behalf. Some of the classical definitions of agentic are: it actually discerns what it sees, it reasons what needs to be done to achieve a task, it performs that task for you, and it learns along the way. We started working with this about 3 years ago. We partnered heavily with Anthropic just in the last 12 to 18 months on this, in fact, to leverage these capabilities to answer that one question everyone asked me everywhere I went in the trade show. When can we start automatically generating automation from high-level instructions? And all the pieces came together this year. So what I am able to do initially on SAP Fiori, but I think you're going to see us expanding that to any web-based application, as well as some heavy UI applications later this year. I can give it an instruction such as create a purchase order in SAP, or I can give it a list of manual steps. From those steps, it will look at each screen and understand what needs to be done on that screen to achieve the objective of that screen to get to the next one. How we do that is with Vision AI. I'll talk about that in a minute. It then auto-generates the Tosca automation in that moment and runs it to populate all the fields on the screen, push the proper buttons to get to the next screen, and then repeats that process screen for screen for screen until it achieves its ultimate objective. Oh, by the way, if it gets lost or confused, it'll ask for help. It's meant to be an interactive session as well, so we don't have to teach it futility. Say you're going and adding something to your bill of material that's not an inventory. It will prompt you and ask, what about this object? You can give it instructions then to go add that to inventory and continue on. And the test will incorporate that logic. As I said, right now, it's based on our Vision AI drivers, which, although they are universal drivers, does present a certain amount of overhead with it. We're going to be introducing more of our traditional drivers later this year. And just to let you know why that's an advantage, Tosca is an automation platform, can handle over 160 different types of user interfaces. Our sweet spot isn't just SAP automation. It's full end-to-end test automation that may touch any application an SAP system is integrated with. If you've done any length of testing in that realm, you'll know that's those integration points where we really find our challenges. So being able to do continuous automation at the UI, API, and data level across any system. For instance, Any SAP client I've visited, they have on average 50 systems that touch it, really is our strong suit. And bringing agentic test automation to this allows us to generate a lot of those artifacts up front, whereas in any traditional SOW, we would have a very large time sink to get the foundation laid. This helps us overcome that. Now, we talked about Vision AI a lot. Why is it different? It is actually not generative AI. It's what we call targeted machine learning. We actually introduced this in about 2018 and 2019, if you can believe that. Think about it as facial recognition for UI level automation. If it looks like an edit box, we're going to treat it like an edit box, regardless of what technology it's written in. In fact, it's powerful enough where I can literally build my test automation from mock-ups, even if they are hand-drawn mock-ups, build my models, and when the live system comes online, it will work. When our chief product officer first introduced this, in fact, he stood on stage in Vienna, drew on a napkin a picture of a login box just to prove his point, took a picture of it with his phone, slacked it to himself, and built the automation from that. This comes in handy in the Oracle world, where Oracle provides mock-ups for their quarterly releases. A certain fast food chain here in the United States uses this to great effect and cut their testing time by 75% because they're able to build the automation from the mock-ups. You can drive automation through Citrix interfaces, through RDP hops. I even drove it over a Zoom call once. But what this really resulted in, apart from being a universal driver that can handle any technology, it became the eyes of our agentic capabilities. So our agentic agents could look at a screen and discern what they were seeing and then reason how to proceed to that next step. So the combination of these two allows for the automatic generation of model-based test automation. And that's key. There are a lot of agentic capabilities out there that will generate a script, something that has code. Tosca does not have code. It is purely visual. Hence why it's easier to maintain, and hence why it's easier to read for the business. This is the only capability that will allow you to do that in such a manner. Now, I mentioned we were really founded on the ability to tackle that maintenance trap. That's what kept us from being successful in test automation. That's what kept those test automation rates low. And model-based test automation got us a lot of the way there. But around 2020, 2021, we decided to take another type of machine learning to this problem, the concept of a neural network that would allow for our test to become auto-healing or self-healing, if you will. And in this way, if we're executing and the test encounters, let's just say, for example, a button that's undergone either a move or significant changes or a label change, it doesn't stop the test. The system goes through its neural network and determines what is the most likely new set of properties for this button. And when it finds that, it's able to go ahead and press the button and continue on. Now, one thing I kind of alluded to in the last slide is we're big believers in human in the loop when it comes to quality engineering. I mentioned with the agentic agent, you can have an interactive session. So if it gets lost or starts to go astray, you can correct it. Same thing with self-healing, because how do we know that's not a defect? So at the end of the test execution, you can look in the log and it'll tell you, I made this assumption and clicked on this button anyway. If this is incorrect, well, you've just found a defect. But if it is correct, click here and I will update your entire test suite. When we were doing some proof of concepts around Workday, in fact, this came in handy tremendously. In fact, during the POC, one class of button throughout the entire Workday platform changed on us, broke everyone else's automation. But our self-healing was able to capture that, and we're able to update the entire suite. So not just about being able to generate tests faster, but being able to maintain those tests, all in the name of running our tests more than we're fixing them at a rate of 90 to 95% coverage. Now, what do I mean by coverage? When Wolfgang founded the company, he said risk is our currency. And whenever he talked about coverage, it wasn't necessarily just functional coverage. It was risk coverage. Where is the risk in the system? Where are you focusing your efforts? And our first foray into this was actually a tool we're not going to touch on today called Live Compare, strictly for the SAP arena. And we knew eventually we needed to broaden this in a couple of ways. One, we needed to support more environments, obviously. But two, it wasn't just about finding the risk. It was about quality intelligence. And one of my fears with all these new capabilities around AI and agentic is it'll basically give people license to create hundreds of thousands of test cases that may not provide value or may not be necessary. We definitely don't have the bandwidth to always run everything every time. That's why Wolfgang's first concept, let's do less testing, but do it more intelligently, comes into focus here. And I'm glad to say with our Sea Lights acquisition last year, we're now able to expand this into other environments with the same concept. For any change that comes into an environment, I can map that directly to the tests that affect those functional paths. And this has resulted in a massive savings in the amount of tests we need to execute. In some cases, 70, 80% savings of effort so that we only run the tests that we need to. In fact, I've seen some case studies where for customers using immutable infrastructure, where you spin up your environment in the cloud and spin it down when you're done for testing, save $50,000 to $100,000 a month just in environment spend because we weren't running everything every time. In this new age of quality intelligence and agentic, this is going to be key. We need to have that intelligence up front to make sure that we're only running the tests we need to run. And then by leveraging AI to identify, auto-generate, and maintain these tests, this is how we keep up with what AI is bringing to the development community, where we're seeing a 10x faster volume of code coming at us. As quality engineers, we're the last line of defense against that. This is how we keep up. We fight fire with fire, but we need to make sure we are still injecting quality and ensuring there's value in everything we do. That's why I'm so excited to be working with them. And I'm seeing in the community, they are really leading the way in this concept in other areas that Tricentis doesn't even touch on. And I really think the combination of their people, their processes, their technology, leveraging our technology where need be is really the key to helping you keep up. And with that, I want to turn it back over and talk more about how these combined offerings can help.
Thank you so much, Bill. Yeah, so as Bill said, using Tricentis as a tool would significantly benefit across SDLC, as I said previously, be it in test design, execution, or even in optimization with various features, as Bill mentioned about using agentic test automation or using your Vision AI plus self-healing while doing your maintenance test execution. Like once your model-based scripts are developed using traditional approach, wherein I don't use Vision AI. No, the beauty of Vision AI is you can shift left your testing, and you can start early in your development lifecycle. Whenever the user starts with a development team starts with Figma screens, so right from that level, using the concept of Vision AI, you can take that Vision AI to Figma mockup screens, and it would intelligently identify and classify the UI elements into across different buckets as a button or a label, or maybe even as a list box, so on and so forth. And the accuracy of identifying them into different buckets and then assigning the properties intelligently would significantly save time post the screens are built, and then once you start automating them, because initial ground up of the work wherein I would generate the model and then assigning the default properties for certain elements, so all these activities are done in tandem with the development team. So that's why you can do your real shift left testing with using the features that are provided by Tosca. So we have used them successfully for a few of our customers, and they were pretty happy, wherein we would actually prove them the benefits of using Vision AI, wherein we would really do the shift left testing using these tools. So how do we bring in the synergy, or how do we enhance the features that are provided by Tosca on as a preferred partner? We wanted to add more value add on top of the existing features rather than reinventing the wheel, because Tosca has done the basic ground up, so that we need not start from scratch. We would leverage those features and then add, sprinkle few features here and there using a concept of uh, building connectors, or maybe using developing extensions. So that's what work we have been doing. So for that, what we essentially I would showcase the demo in a couple of minutes from now. So the essential idea is, yeah. So this is what we are trying to do, wherein leveraging the existing Tosca features, we are kind of augmenting this AI features by leveraging your OpenAPI LLM or Mistral. Using those APIs, we would connect to the Tosca execution logs, Tosca commander logs, using REST APIs, or sometimes even downloading the JSON format of the execution. Once your test cases are well written, and then once you execute them using by enabling your vision AI and self-healing features, we download those execution logs, the Tosca Commander execution logs, where with the self-healing and vision AI applied, then what we essentially do is, we write a small Python code, wherein we would take a subscription of OpenAPI LLMs, keys, and what we essentially do is we would kind of clean the logs at times, because Tosca logs are defined to actually showcase what has actually happened from the Tosca UI. So sometimes, at times, what we have to do is to clean up these Tosca logs and then add a few things here and there to polish the logs, so that these logs are taken as input, and fed as input to your OpenAPI LLMs, and then we build a contextual RAG, and then intelligent prompt engineering techniques. We would able to kind of generate more, like what exactly has happened during this test execution, how this self-healing is applied, or what vision AI is applied, uh, and by elaborating the what exactly had happened behind the scenes, so that uh, when uh, you know when certain thing has, let's suppose if some test case has broken, what fix was applied, whether agentic AI feature, whether self-healing is applied or vision AI applied, what really worked. And we are, so Tosca has also it does provide including confidence score also. So we would also clearly state them in a plain English like statement, a simple document, which would clearly give a solid evidence of what actually happened by polishing the logs. So that way, it would we could gain the confidence of an automation engineer rather than relying on the logs. You are taking a help of OpenAI LLMs to really enhance what exactly had happened behind the scenes, by enhancing the logs, Tosca logs, and then that's where it would actually benefit. In that piece of information can be shared across your higher management to really prove what actually has happened. And using the same RAG based model, once you have the context of what exactly this test framework have done, we could intelligently pick up those relevant test cases based on the code fixes or code changes that are happened as a part of regression cycle, and then we can significantly reduce the regression time that is being spent uh, during the test execution, wherein you can significantly accelerate your time to push your build to production. So I would share a small demo, like how actually we kind of built a small connector on top of these logs. I hope you can see my screen. So we have kind of uh, downloaded these Tosca logs in the form of JSON. And once we have these logs, so what essentially we do is we use OpenAPI GPT model, since they are we have got subscription and we closely work with them. It's not restricted to Open API. We can use Claude Desktop or even Mistral. So there are, or even Gemini, wherein you take these logs and then using intelligent prompting, you can enhance this. I'll execute like what we basically would do. So what we have done is, so this is what the sample code that we have written, and then we connect to the Azure Open API and we provide the keys. And so once this is done, we kind of write an intelligent prompt, and then we parse in the logs, polish them, then we analyze the logs, essentially saying that, hey, take these logs and then analyze them and then provide me what exactly had happened. So we have kind of enhanced, we took the sample logs and then we have kind of included step names and then durations and whether if the vision AI is applied, what has happened. So once these logs are kind of polished, once you execute them, it would analyze the logs and it would give me a comprehensive document of what exactly had happened for this test case. So we have taken one end-to-end application using Orange HRM, a real life application. So this would give me a complete picture of what had happened. So I've taken, I'll pause it here and I'll show it in the Word document. So it would actually, give me a comprehensive executive summary of what has happened with the Orange HRM application. What is the workflow that is involved? Like we have taken a leave application wherein I would do a submit and then approval process. So it would say clearly what has happened, where actually it has implemented the self-healing, and it would give me a clear step-by-step detailed English statements. So it's not, we are kind of complementing what is being provided by Tosca. Tosca does provide these information in the form of a simple HTML log in the Tosca commander, but we are kind of enhancing this so that if you see this statement, like for example, what has happened, I have opened the open Orange HRM browser, whether it was successful and how much time it took. And this is where your Vision AI feature has implemented, and it was able to successfully identify, as I said in the previous couple of minutes earlier, we have used a snap of this Orange HRM and then try to identify the controls using Vision AI. And it could able to identify the login page header with a confidence of close to 1, almost indicating that it was able to correctly identify the application. So then what happened during the second step, wherein the self-healing is actually activated, it modified, there was a change and it kind of applied a new locator with the successful one, and the confidence rating was 0.89 after healing. So like that, for every step, we would give a comprehensive detailed summary. This would really be helpful, or it would be a confidence boosting for even for an automation engineer, where he would really go and see your agents or a generative AI is really working behind the scenes, and once they see it, it would actually boost the confidence, and they are more willing to trust the automation repairs that has been really done by the tool in a smart way, rather than just for the sake of saying it's actually doing this. So that's where confidence of automation engineer would also increase, and so he would trust that it is acting as a partner, rather than nowadays there is a strong belief that with the introduction of agentic AI and generative AI, jobs would be lost. It's actually complementing the engineer, wherein it would really enhance or boost his productivity. So this is one accelerator we have built in. So we are working on multiple such accelerators on the base that is being provided by the Tosca, using your Vision AI, be it self-healing or using the intelligent generation of test cases in the test design phase, where I would go and understand your user stories and acceptance criteria from the Jira. Again, using the similar principle, the architecture principle would pretty much be the same. Let me go to the slide. Yeah, so this is what the underlying principle that we use, where you essentially talk to Tosca, get your logs, because logs does provide a whole lot of information. You download the logs in the simple JSON format, which would be understandable by any programming language. Then you really play around with the logs, and then once you got a meaningful information, again using your REST APIs, talk to your Q-test or maybe Jira and then raise defects. So that's where you can use AI across your SDLC and then boost the productivity rather than reinventing the wheel using open source technologies. So it's not just in a simple web applications we have done. We were even able to do it even for complex ERP applications like, for example, SAP, or maybe even in Salesforce, as Bill said. You take up this mock-up screens, and there are certain things which are standardized there. So once you do this shift left approach using your Vision AI, and then once you have a strong domain expert who understands the ERP landscape, using your AI features across your design, execution, and optimization, you could really enhance or boost the productivity. So we have done it for one customer. Probably I'll let Sri Lakshmi talk depending on time, and then we were able to significantly enhance the test execution for SAP. Like, for example, dynamic test selection. We were significantly able to make progress. Around 30 to 40% of the benefits were realized. So again, the approach that we followed was pretty much the same. The underlying approach was same. So just to conclude, or I want to emphasize, or to take up the main point. So essentially, when you bring in this agentic AI features into your existing SDLC, you're not replacing your testers, or or maybe you're not changing, or you're not dynamically changing any of your existing processes, but rather it is amplifying them. It is kind of complementing the user as a pair partner, like the way developers would work. One developer would write the code and other one would be reviewing it. The same approach would be taken, but so same approach we take, and it complements the whole. It would lighten up the burden and most of the occasions, and then it would significantly increase the return on investment for customers spanning across ERP or even a complex web applications, spanning your distributed architecture. So it really helps. So we have tried this, and customers are kind of happy. Not necessarily using Tosca. Yeah, so we have been using Tosca heavily, and then kind of showcasing the value add that we are kind of bringing in, and they were very happy when we send in this executive summary in a more concise form, saying that we were able to reap in the benefits using these features. That's it from our side. So we are open to take up any questions.
Just want to add one thing. I love how you ended this point on it's not meant to replace anything. It's meant to augment and enhance.
Yep.
One rule of thumb I like to use is imagine you had 20 graduate students now on your team. How would you use them? What tasks would you give them? And would you trust their work without checking over it here and there, at least spot checking? So I think that's a good rule of thumb for how we're starting to apply these agentics into the QA workflows. And that frees us up to do higher level tasks, to return to critical thinking, and to understand how do we change the culture of a quality engineering organization in order to fully take advantage of all this. And you really have to ask yourself, is your QE organization ready for that change? Because we have this velocity from our friends and developers coming at us. This is how we keep up. So thank you so much for sharing this approach.
Yeah, thank you so much, Bill. So,
okay, any questions coming in?
I could see a couple of questions in the questions tab. Sreeram and Bill, you would like to pick it up?
Let's see. I'm now seeing the first one. I'll go ahead and read it. But I think the answer is going to go back to Innominds. In what ways does AI-driven test design accelerate authoring and data coverage for complex test scenarios? Do you guys want to handle that one?
oh yeah, absolutely. Yeah. So to answer your questions, again, we need to really start small. You need to really understand at what level you really wanted to apply these agentic features. Is it at a design level, or maybe at execution level, or at an optimization level? So it's not a panacea or a general rule of thumb that it would really solve all of your problems. So like the way we start automation, right? For example, you have to really understand what is the problem at your hand, and then systematically develop framework. The same approach applies here as well. Like for example, let's say you wanted to bring in AI adoption into your culture. I think the best way to start would be to use or to subscribe to the Tosca Copilot. And then if you have an existing framework, some model framework, that is model-based testing that you have already developed, start asking questions, a simple NLP like questions, to understand how your individual modules are written, what sort of parameters are passed, how this values are being stored. Like for example, all the technical intricacies of Tosca, like buffer handling, or dynamic executions, which are naive for a fresher, as Bill was saying. So you can ask simple English like questions, and it would kind of summarize how the code has been written, what are the different variables that are being passed, and that way it would accelerate the time a senior engineer has to spend the time educating the person. So I think that would be a good starting point. We have done it, and we could replace I would say 3 to 5 years engineer with a junior guy, and then he would able to write ask NLP questions, and at least able to generate modules, and we were that way you could slowly reap the benefits. Yeah, do you want to add any other points on top of that?
Excellent. No, I think you hit on all that. I think we're going to get some more along that same theme with the second question. I'll tackle it initially. We had a participant asking if we could share examples of where LLMs or AI in general have shortened test triage time in actual customer projects. Now, I can interpret triage several ways. One could be making sure that we're only running the necessary tests. Another could be making sure we identify the tests that need to be repaired. And I can give one example for the former, and then I'll turn it over to you, hopefully for the latter. We had one project where we had a test suite already established when we walked into the account of over 10,000 tests. Upon doing an analysis of those tests, we discovered that the actual risk and functional coverage was 7%. 7%. Customer didn't believe us. We brought in a third party to certify that our technology was actually calculating that correctly, and they came up with 6%. So all that is to say is that's why we need quality intelligence up front to understand not just what tests need to be run, but what is the usability and value of our current test suite. That's one way I can see triage. There are capabilities as well in the technology that will help identify which tests need to be repaired and updated as well. But since they're talking about actual customer projects, I want to turn it back over to you. Perhaps you have an example as well.
Yeah, so you pretty much covered it. Yeah. I echo your statement. Yep.
Excellent. And one last one, and I think I can tackle this one. What specific advantages does Vision AI provide when combined with generative reasoning from LLMs? So as we talked about, Vision AI is the eyes of the LLM. It basically facial recognition for doing UI level automation. I mentioned earlier, if it looks like an edit field, regardless if it's hand drawn or actually on the screen, we're going to treat it like an edit field. This was a big step forward in tackling very esoteric automation challenges back in 2019, 2020, and it's continued to be trained every day since then with millions of examples, so that it's become our universal driver across any technology. Even though we have 160 plus other drivers that are technology specific, this one covers the gamut. I mentioned that it helps you shift left by creating your automation for mockups as well. But when you combine that with the power of an LLM, that's where you get the agentic component. It is the eyes of the agent that creates the Tosca automation. Through Vision AI, we know what's on the screen. We know where the edit fields are, what they're labeled, what the button is, what the layout is. The LLM provides the reasoning for how we navigate through that screen, what data we apply, and where to achieve the objective of that screen, and then move on to the next screen, et cetera, et cetera. So think about Vision AI is the eyes of our agentic. And as I also mentioned, you'll see us incorporating those other traditional T-box drivers into these capabilities in the very near future. Right now, our ATA tool provides you tests completely in Vision AI format. Even though Vision AI will continue to be the eyes and ears, you'll see that in T-box format in the very near future. So hopefully that helped answer all the questions. And I think those were all the ones that came in. Anything else to add to wrap us up?
Yeah, I would just wanted to add the Vision AI thing. So we had one customer, an insurance customer uh, who is traditionally on the script-based testing, where they have heavily invested on the resources to build the framework using Java plus Python combination, wherein they would do this end-to-end tests, validating UI, database, and APIs and stuff like that. So it was doing good, and they haven't kind of migrated from Java applets technology. They were still sitting on Java applets, and they're reluctant to migrate to new Java, Swing based applications, or maybe revamping their web. So they have asked us to, come up with analysis of the existing tools in the market, which would really help them to automate or reduce the complexity of their automation using low code, no code tools. So we have kind of suggested them Tosca by taking one end-to-end scenario and then really showcasing them, because one of the challenges they were facing was to identify the controls, wherein their controls have this dynamic properties, and the properties were not static. So we have used this Vision AI feature and then really help them to identify the controls which are sitting in Java applets. So yeah, so we were
Excellent
able to
example.
do that also. Yeah.
We did have one or two more questions come in. I think we have time for one more. Can you share examples where AI adoption and quality engineering directly impacted time to market or customer experience? I'm going to turn that one over to you.
Yes. As I said again, the same answer. So to reap in the benefits, you really need to start slow and then really understand where you want to see a significant bottom line impact. Is it in you wanted to save time in writing your test cases by understanding the requirements, because every team would have different challenges. Are you facing serious problems in understanding your ambiguous requirements, and then writing your manual test cases, and then kind of you're spending a lot of time there? Yes, then in that case you could use your copilot or agentic test automation, wherein you extract user stories, give it to store it in a context, and then using your rack based and prompt engineering techniques, you could significantly save time generation of your manual test cases. So that is in, if you are seriously facing problems at the design state. If you are happy generating, you have good number of junior guys who are experts, right, understand your test design techniques, and they are able to write, test cases covering your boundary value analysis, positive, negative, and whatnot. Then, if you are facing problems at your execution level, yes, you have again features of Vision AI and self-healing. Leverage those features and significantly reduce your maintenance time. Last but not least, if you want to optimize the existing processes, again you have like, for example, if you want to optimize the regression time, again using the intelligent mechanism, identify the heat maps and then figure out what code changes is really impacting your test cases and only execute them using AI features, and again that would give you a benefit. So it's not one size fit problem. You need to really understand where your problem is and how you want to reap the benefits.
Absolutely. And that goes back to that culture change. Every
Yeah.
organization is different.
Correct. Yes, correct. Culture change in adapting this, because people are like little scared adapting this, the same approach where, once we started with this automation, people were really scared about jobs, their jobs getting lost because of automation. The same thing is happening now with the generative AI. So it's a cultural shift, as Bill was saying. Yep.
Absolutely. I think we were right up on time. Any final thoughts? Then I would just like to thank everyone for going on this journey with us. I hope you saw some examples of where we can leverage machine learning, generative AI, and agentic AI to help keep up with this code tsunami that's coming at us. The pace of change today is as slow as it will ever be again. Multiply that by the dozens of systems we now have in our ecosystem that we have to support as quality engineering from an end-to-end perspective. And I think you'll see a combination of these capabilities, front-ended by quality intelligence, using generative and agentic AI to get a step ahead of the creation and maintenance of automation, as well as make sure that the foundation of that automation, everything that goes into refining the requirements, the manual steps, etc., is as solid and as rapid as it can be with human oversight. This is how we keep up with this new world. So if you have any questions, please feel free to reach out to us afterwards. And I know our friends at Innominds will be glad to work with you on that.
Thank you so much. Appreciate your time. I think we are good.
So thank you, everyone, and have a great day. We look forward to speaking with you, hopefully in the near future.
Thank you. Thank you.
Bye.
Thank you.